In this video, we're going to be talking about water pressure, head, and water pressure loss due to loss in the head height. And what is pressure? Pressure is a measure of force per unit area. And generally, we're going to be using units for PSI, pounds per square inch. In the metric system, it's Pascal. Pascal is pretty small though, so generally it's kilopascal, and kilo means 1,000, so it's 1,000 Pascal. A Pascal is newtons per square meters, and 9.8 newtons is 1 kilogram, to give you some idea of the size. So pressure, it's really the weight of water above a point. And we're going to be looking at the relationship between 1 foot of head and this area, the square area of that cubic foot of head. And you're probably wondering, what is the weight of a cubic foot of water? And it's 62.5 pounds. And they use that weight of a cubic foot of water, got the foot of the head, and then find the area of that base of 144 square inches. And if you take that weight divided by the area, you end up with a PSI of 0.434. And that's going to be the basis of a conversion we're going to use for finding the head and the pressure. The head is the amount of pressure created by that 1 foot of water, and it doesn't matter the size or the shape of the tank. So it could be rectangular or it could be round like this one. It's the 1 foot of head that really matters. So pressure is going to be equal to 0.434 times the head, and head is the feet of water. So the higher up the water tank, the higher the water tank is above the ground, the higher the head will be, and the greater the PSI. Since 1 foot of head exerts a pressure of 0.43 psi, that pressure of 0.43 psi raises the water column by 1 foot. It's a reciprocating relationship. So the question then is, well, how much is 1 psi? Well, 1 psi, if we do the conversion, we can flip that over, the psi's will cancel out, and we end up getting that 1 psi is equal to 2.3 feet. So 1 psi will raise the water column by 2.3 feet. Or there's a loss of 1 psi for every 2.3 feet of height. That helps give us our other formula that we're going to be using when we're solving problems involving pressure and head. So if we want pressure, we can use the formula 0.34 times head when it's in feet. And if we want to find the head, we can use 2.3 times the pressure. So here's a question. Determine the head produced with a pressure of 75 psi. So we'll use this formula, and then we'll put in our pressure of 75 psi, and we'll get the head of 172.5 feet, and that converts into 172 feet, 6 inches. Next question, what is the water pressure on the 4th floor of a building if there's 60 psi on the 1st floor, and assume 12 feet per floor? So first thing that we need to do is figure out how many feet up you'll be. So let's look at the building. So if you look at the floors of the building, some people think we'll just do 4 times 12, but you don't need the pressure at the top of the 4th floor, you need the pressure at the bottom of the 4th floor. So you're going to go up 1, 2, 3 floors, that's going to be 36 feet. So there's going to be 36 feet of head. So to find the pressure at the 4th floor, we're going to do 0.34 times the head, and we're going to have 15.6 psi. And that's the head loss due to that height. Then we're going to take our 60 psi and determine the pressure difference. Take our 60 psi and subtract the 15.6, that's the loss, and we end up with 44.4 psi on the 4th floor. So you lose psi every time you're lifting the water up floors, and you end up with 44.4 psi on the 4th floor. So I hope this video has helped you understand water pressure and head a little bit more, and you'll be successful with this subject.